Hi, my name is Hui Hui, and in this video, I'll be discussing about the first question of the May-June paper 429703 Chemistry 2023. So, group 2 carbonates decompose when heated to form the metal oxide and carbon dioxide. Suggest a mechanism for the decomposition of the carbonate ion by adding two curly arrows in figure 1.1. So when you look at this figure, you know that carbon dioxide has two double bonds. So from a carbonate ion to form two double bonds and one oxide ion, first the lone pair, it has to form the double bond first. And since now the carbon, it becomes partial negative, it will then donate its negative charge to form this oxide to an ion. And that's how this will become the double bond here. And then this O minus will become an isolated O minus, O2 minus. So the answer, you should just include these two curly arrows, and that's enough. Describe the variation in the thermal stability of group 2 carbonates. Explain your answer. So usually start with your answer by going down the group. Going down the group. Then you write your answer because it didn't mention going down or up, so you should. I think it's safer to include the word going down the group. So first you need to talk about the cationic radius. And please be more specific and use the word, the term cationic instead of ionic or atomic, because actually atomic is wrong. In carbonates, you are involving cations and anions, and CO3 2 minus, right? Having this is the group 2 cation and also the CO3 2 minus. So it's wrong to use atomic because you're involving ions only. And other than cationic radius, you need to talk about the charge density. And then write about your conclusion. Going down the group, obviously the cationic radius, it increases. That's why your charge density will decrease because your charge remains the same. As charge remains the same. Because when your charge remains just 2 plus, but your radius keep increasing, the density will decrease. So even if you don't memorize it, just think logically and you can get to the answer. So conclusion, since your charge density decrease, your lattice energy will become less exothermic, your ionic bond strength becomes weaker. It's easier to decompose, you don't need large amount of energy, so your thermal stability decreases. Becomes your thermal stability, your carbonates becomes less stable, they are easier to decompose. That's the meaning behind this. Next, define lattice energy. So for these definitions, especially in enthalpy change, I think it's easier for you to take an example of what it means by lattice energy. So it's from, for example, I'm using sodium, then it will be a sodium plus gaseous, it becomes solid. So from this equation, you just write what you understand from this equation. And then you'll get to your answer, which is enthalpy change of the formation of, because it didn't mention standard lattice energy, so you don't need to specify about 1 mole. So it's just enthalpy change of the formation of the solid lattice ionic compound from its constituent gaseous ions. So lattice, and you have like Cl minus, and then you form NaCl. This is the solid lattice ionic compound. And then the constituent gaseous ions refers to the Na plus and Cl minus. If it's just like Na plus, if it's Na becomes Na plus, this is the first ionization energy of sodium. So don't mix it up, and then you'll get the 2 marks here easy. The lattice energy of the group 2 carbonates, MCO3, becomes less exothermic down the group. The lattice energy of the group 2 oxides, MO, also becomes less exothermic down the group. Lattice energy MCO3 and MO change by different amounts down the group. Suggests how the standard enthalpy change of the decomposition reaction for group 2 carbonates changes down the group. Explain your reasoning in terms of the relative sizes of the anions and relative changes in lattice energy down the group. So this is actually quite not a common question in A levels, because now you are talking about the relative sizes of anions and compare with its relative changes in lattice energy down the group. First, don't panic when you see such a long question and you think that it's going to be hard, because it is not a common question, I would say. But now look at the first part of the question. It talks about both becomes the lattice energy, both of MCO3 and MO, both becomes less exothermic. But now it mentioned different amounts. So which one becomes less negative? I like to use the word negative because it gives a clearer picture for myself to understand, and it's easier for me to work for my thinking process to tackle this question. And I like to show you something that I've written before, which I think is a good reference on how you should understand the question. What is the question? So since both are saying that MCO3 and MO, the lattice energy becomes less exothermic, let's think about how does this two MCO3 and MO relates. So you know that when carbonate ion, look at the Roman A1 question, you know that CO3 2 minus will become CO2 plus MO plus O2 minus. So if it's actually like suggesting your carbonate, metal carbonate here will form this. Sorry, I forgot the which is the decomposition of MCO3 to form MO plus CO2. And now your decomposition and how it relates with lattice energy. I want this MCO3, it is formed from M2 plus C4 plus 3 of oxide 2 minus anion. And MO plus, MO is formed from M2 plus O2 minus. This is, but CO2, it will also be formed. So to form a Hassel cycle, you need to include the CO2 as well. So the Hassel cycle is balanced. And now the question says that the lattice energy of MCO3 and MO change by different amounts. So why it changed by different amounts? It asks you to explain it in terms of relative sizes of anions. So look at the yellow part of the diagram and the green is the explanation. So your oxide is smaller than your carbonate ion. That's why when your carbonate ion, it doesn't affect the lattice energy that much when your cationic radius is changing. As you can see, the cation and the anion, this change to this, the Ca2 plus, when it becomes smaller, Mg2 plus, it's not significant in your metal carbonate. That's why compared to like your oxide and your calcium oxide and magnesium oxide. That's why the change in cationic size is less significant in MCO3. So the ionic bond strength does not decrease rapidly. And when it does not decrease rapidly, your ionic bond strength doesn't change much when going down the group. Your lattice energy will become less negative or less exothermic at a lower rate. It will become less exothermic slower, meaning to say. And going back to the question, when your lattice energy becomes slower, your carbonate MCO3 becomes less exothermic, slower than magnesium oxide. Because CO3 is larger than O2 minus, your decomposition here, go back to the Hassel cycle, it becomes more endothermic. So sometimes when you are confused, label it as A, B, and C. So from the Hassel cycle, you know that this is equal to this. Okay. So your C plus A is equal to B. So you want to know the decomposition part, the enthalpy change of decomposition. Your A is equal to B minus C. Now your B refers to this part. I should label it like this. This is A, B, and C. So your B refers to your formation of MO plus CO2 from its ions, this minus this one, like you're reversing this, then that's why you need to minus your MCO3. And since both are lattice energy is always negative, but your MCO3, it becomes less exothermic slower. So if we have a graph here and we are comparing like radius to energy, magnitude of energy, we are not talking about it's negative or positive. This is magnesium oxide. But this with a smaller gradient, this line refers to MCO3. And for example, we are taking this point and this point. So this has a lower value compared to MCO3. The magnesium oxide has a lower value compared to MCO3. That's why this is negative and this is very, very negative. So maybe let's say -1 minus -5, you'll get a positive answer. That's why your enthalpy change of decomposition, it becomes more endothermic. So your answer should write about your MCO3. Sorry. It's your relative sizes to anion. So just mentioned about CO3 2 minus has a larger anionic radius than O2 minus. That's why the change in your MCO3 becomes less exothermic. Less exothermic or negative, slower or at a lower rate. That's why your decomposition, enthalpy change of decomposition of MCO3 will become more endothermic, which is also same as if you put positive. So I'll conclude my video here, and thank you.